Million to power million. Good morning, everybody. Namaskar. This is Suraj Singh speaking from Bharat India on this day, April 1st, 2022, Friday, 3:22 a.m. Today is the start of new financial year. This April 1st. I'm not celebrating that as April Fool, but as New Year financial year in this country. 1st April 2022, Friday, 3:22 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल of communication, concrete specifications, civil engineering, contracts, safety, health, environment, designs, methods, disputed claims, parties, what we are. Let us hope for best for everything. And this is title and starting from real quality at one end and ending with what we are at other end. And that's what is required. Frame rate varying very fast, but let us see, let us hope for best. This is my, as usual, identification board, and it's for purpose of email ID, that is Suraj, SURAJ underscore engineer, ENGINEER at yahoo.co.uk. You know what is written here: Chartered Engineer India and International Professional Engineer India. And this is my certification, 5-year certification for International Professional Engineer India. This is international registration under provisions of International Professional Engineer Agreement, that is international agreement. And this my certificate is valid till 30th September 2025. Then it is Chartered Engineer certification, Chartered Engineer India, which is according to Royal Charter of Institution Engineers. So you can see Institute of Engineers Charter 1935. This is that designation linked to corporate membership of Institution of Engineers India, and I am that corporate member, entitled fellow, that is fellow of institution. And then it is quality file, as usual talk about. This is coordination file, and this is concrete specifications from Japan, which I have been using for reference. I thought this is of course indicative, but reference kind. I put off this file, I close this file, fellow. I also close this file of Chartered Engineer. We concentrate on quality file, real quality and real coordination. Every day I talk of, and I think you people must be boring, feeling bored. Every day same talk. Yes, every day same talk, because boring is also very important. If you don't feel bored, you don't know value of happiness. You don't know value of interest, profession. Either you feel bored in profession or you feel pleased. It's up to you. How do you feel? I think life is itself boring, in fact. And profession, of course, and work you can say related to profession. But in engineering, I think I don't feel boring. And in fact, not only in engineering but also in all other works. If you work honestly, sincerely, if you think using your mind and do successful delivery of what you contemplated, you never feel boring. You feel boring only when application of mind is absent. That's what I think. Maybe your thoughts are different, I can't say that. And that's why I say real quality and real coordinations are very important. And if you go down to that, you will find many I'll find something which I'm interested in that, and it can be said that thinking and all that, thinking, synthesis, as I said, no concession without analysis, as we said here. Quality, reliability is defined, and we also say that reliability, risks are involved in this, cost is involved, time is involved, as we usually consider. These are certain factors we cannot leave them. Construction method statements are involved, which I say being must for works implementation and therefore must be charted out professionally. And also we can say, so these are certain points, certain references, I could sort of say, that it can't be brought back. It is irrevocable. If we lose it, we can't recover it. And this is only money. Money means money in a sense of use, and if I don't use time, I cannot use it again. If I lose it, I loosen it. Cost, I think cost originally is nothing. It is just in relation to time. But cost may be recovered, it may not be recovered, but time lost cannot be recovered. And then you can say risks. Risks are such important that intelligent person, analytical person can understand, can foresee what sort of risk will be there. And by experience also we know how to think of that. And also we can say reliability, which is very complicated word, complicated in the sense that it's not single verb or some adjective, it's a sequence or consequence, or you can say it's a kind of thread or it's a kind of string that you use in word, and that includes safety from all involved factors, and successful serviceability of intended purpose, and mandated durability. Durability, safety, and serviceability are very important factors, a minimum required. There can be added upon it many more. Value addition, or you can say all other risks that cannot be understood. Safety covers everything. Serviceability also covers purpose of this, and also long distance travel, I can say durability, or it should work for. This is what design has been input in this. What was purpose intended to be? It should work in same capacity as it was thought of, or even better for long term, for life of product we decided, which would be 100 years, 50 years, depending. And therefore, civil engineering is particularly that one. And then comes analysis. Analysis, which is, you can say, educational power. Analysis. Education should teach us about power of analysis. In our education system, our professional system, or whatever we learn, if we are not equipped with potential of analysis, I can simply say, then I can't call myself educated, say I'm a doctorate, I'm master's. But if I cannot analyze, I think analysis is a real word in place of critical thinking. Thinking is not enough if I can't analyze what I'm thinking. And thinking is also related to analysis, and there may be many points, many sequences in analysis for some problem to solve, or to understand, even not even to solve. Observe something and understand it, analyze it, and that sequence, if you do it correctly, it can be called a, you can say, okay, this is system of this activity, this system of this, observation, or this object, or this system, whatever you can call it, entity. And you can say, I understand this completely, I've gone through its study, and my analysis says that it works like this. And that's also analysis, though you have not added anything to that, you have not designed that. But try to analyze and try to go through in this through total scrutiny, and you reach somewhere, okay, I understand this way. And that's also called analysis, means in fact science is based on complete observational analysis. Engineering is based on complete analysis. Analyses are to be conducted, and then we can say reconstitute them into another system, and which we whatever we understand through analysis, we try to again into a different string or same string, and that's called recombination. Though physically it's not that, but mentally, what we understand, we combine them together, we link them together again and again, and so this is final form of that. So analytical work and synthetical work both are important. Both are linked together. It doesn't mean physical change. It is really reorganization, you can say. Synthesis can be called organized, and you can say analysis can be called study of every organ within that synthesis. So you can say analytical based engineering result to apply an analytical based performance by chain, and therefore I think it's very important to understand that. It's written in Hindi here, सोच तथा एकाग्रता अत्यंत आवश्यक, which means thinking is सोच and concentration is एकाग्रता. Thinking and concentration, certain powers. These are, I can say, property of thinking, or as a title or a might of thinking and might of concentration. If we combine together, we can say this is power, because thinking is done due to your potential of mind. And of course, potential, if you have a combination of various potentials, can be defined as power to some extent. And thinking plus thinking and thinking, if you think and think on same topic for long, it can be called concentration. But you do not divert from the focus on which you are thinking, and we keep on that, and you get more and more powers from your mind. This is practical. There's no requirement of any medical study on that. It is observation, feeling, experience. And to achieve everything, that power you should have. If you have that power, you shall apply that. If you get that power, that concentration, there is no way that you can leave it behind and go away, because more and more thinking means more and more concentration, and more concentration means more and more internal entertainment of mind, where you cannot say I'm feeling bored, rather you feel too happy, and if something else comes into your way, you don't like it at that moment. So to achieve everything, concentration and thinking are very important. And we can say that thinking based contemplation and must be achieved, and that's what designs and prosecution works we call it. In fact, design is analytical work, concentration work, and we can say engineering business, and we should not go against that. Whatever we decide, whatever we say, we have to achieve this, and that we have to conform with. And if we cannot conform with that, it's called non-conformist product. Substandard one, you can call it. To what level of substandard is, I can be rejected also, because it's against that provision, against that engineering requirement which we decided, and no concession can be granted to that. Non-conformance means engineer, whoever is involved, whoever it is careless, is ignorant, or incompetent, and therefore it is redundant personnel. Redundant means more than required. And if it's more than required, what for? We use that engineer for, what for? So we can say, if we have to do that, quality requirements are important, and quality means what we mandate. It's a must. And we have to blame ourselves for quality achievement failure. If I say we could not achieve quality and we give some reason for that, I don't think that works. Engineering is very serious as far as work is concerned. It's very happy moment if you successfully do it. Engineering has both properties. If you do not able to get quality and production, you don't feel happy because you could not do that. You could not meet schedule. You could not meet your, you can say, target rather. And this means it's a failure in engineering, both in quantity and quality. And therefore, continuous improvement of quality is required. And if you say continuous improvement of quality, or abbreviated as CIQ, this means it should be completely continuous improvement of quantity also, because quality and quantity live together. They cannot live in separate areas. I am sitting here, Mr. Quality, and I am sitting here, Mr. Quantity. We cannot physically do it. And therefore, we can say no way exists not to comply with defined or specified quality levels, because definition of quality is a must. It is a must, and that definition requires to be achieved, or else work leads to status of being unsuccessful or to be performed. Engineers are problem solvers, not problem creators. Engineers are problem solvers, and engineers are developers. Engineers are agents of change, agents of social change, agents of design change, agents of materials change, agents of geographical change. That's an important point we have to think of. It's not because I am engineer I'm stating that. It's basics of engineering, because engineering means change, change and change. Using mind, engineer can convert a forest or a desert to a city or an industrial town, for which quality and safety, health and environment play integrated and merge vital roles in all respects. No concessions. In public, and if done without quality, you have acted against profession and nature. इन हिंदी संचार तथा संतुलन अत्यंत आवश्यक। सही गुणवत्ता पाने के लिए नो कंसेशंस। Communication and coordination, most significant discipline subjects. Specifications is a must. Specifications are a must. Without specifications we cannot do. In Hindi is written, बिना विनिर्देशों के समझे कोई भी कार्य नहीं करें. Do not do anything without understanding specifications. क्योंकि गुणवत्ता प्राप्त करने के लिए स्पेसिफिकेशन निर्देशों की अच्छी प्रकार समझना होगा. Because to achieve quality, it is required to understand specifications or define specifications in an excellent way. Only then we can apply this to work. Never follow any line which is not followable or which is not applicable to us. No concessions can be given, and if you do not know what to do, stop working, stop doing work without thorough understanding applicable specifications. If you understand that you are doing right and it's done, we can do it, okay, that's fine. Otherwise, if you don't understand in clarity what is to be done, better delay it, because doing wrong job is no good. It is better to delay rather than doing incorrect work, because once you involve material and workers and everything, then break it. It's no use. It's national wastage. It's national wastage and natural wastage both. You cannot carry out work without thorough comprehending specifications, and you must understand what you have to do, and that's called comprehension of specifications. And what I say, just like it's written in Hindi here, गुणवत्ता निर्माण में, जीवन में, सेवाओं में, quality in construction, quality in life, quality in service, quality in every work, quality in education, quality in society, quality in individual. All these are equally important. To an extent, just like we have breathing system in our body, we breathe in the same way quality breaths in works. And therefore it should be in document what we have to do. It should be written clearly. Demand written document and procedures to carry out works, and stop living on verbatims. That's what's important. As said, mobiles, we don't talk too much on mobile, because it wastes your time, it wastes times of others, and unnecessarily it wastes your energy. That's also a point. And you have to talk to others have to talk to you. You have to provide opportunity to everybody. Other person should not wait to contact you just because you are busy somewhere else, and that's not good practice. Don't waste your money, don't waste your time, don't waste your energy. And that's what Bharat, India speaks about. Bharat is Hindi word, India is English. Bharat, India, we usually say that just to arouse people, just to enthusiase people that it is Bharat, we are citizens of Bharat, and we have to be like this. Bharat, India speaks about. We have to be very much happy about that. Real quality and real coordination means real, not imaginary. If real means whatever we define, of what work we have to do, how we have to do, what's its real way, and under what economical consideration we have to do, what's intention behind that, means what purpose, what for it is there. Means we have to define tolerances ourselves, we have to define limits ourselves as engineers or as those who are in power of works, and what employer, or you can say what owner intends for. If something is required for certain and we have to define that requirement. It's not necessary everything should be same, depends on, means what level of quality is required in this, what level of strength required in this, that depends on. And that's what technical specifications of item specifications required, which include on project specifications. So that is what real quality design, you may call it design of quality, and you can also say you have to give in written form, and that's called communication. And written form should coordinate with all such communications. We cannot say one point here, other point somewhere else. That doesn't means you do not do coordination on that. And the real coordination is you have to put all these items in kind of string, in follow-up sequence, or like you say, you should be able to retrieve that immediately. Is what is requirement. That's why I ask, don't sleep. I can't sleep. You can't sleep. When you have job, you have work, you have to keep yourself in arena of quality, you have to keep yourself in arena of coordination, and you have to keep yourself immersed in that, and that immersion is required, and which is real entertainment. Have you ever noticed that you are immersed somewhere? At that time you don't even know that you had to take food or a cup of coffee, but you immerse so much in that, and you enjoyed that immersion. It's like, you got some area where you don't want to leave out, though it was not easy for you to enter, but once you enter and immerse yourself, it's concentrated and unconcentrated or super concentrated in that, and that's it I'm talking of here. It's real entertainment, and that's why in place of boring, you can see you enjoy that strength, because there's a strength, there's a potential getting developed, potential generated, and you enjoy that one. You can see everyone stops sleeping in hours and just say we should not sleep, we should never sleep from viewpoint of production, viewpoint of engineering. If you know something or if you get something to do, you have to try that. You cannot say, and that's why I call these two domains, quality domain and coordination domain. These are very, very important domains, and we have to understand them. Engineers' business is to think. Engineers' business is to think for work, means how to do better work, how to convert that design into real work. Designs are done based on engineers' design itself, when nobody else designs for engineering. It's engineers only who design whatever structure we have to do. Generally, engineers design, and architects design for architectural part, services engineer design for service engineers part, structural engineers designs for structure part. Likewise, for every project, it depends, means what sort of project is and what sort of caliber is required. So we can say demanded quality cannot leave us, you cannot leave us because we are with you and you are with us. And my destiny in work is quality and quantity both. I cannot say I achieve quantity, I don't want to achieve quality, and I myself stay strongly. And for nation and for other cities, if you can understand quality, once you understand quality, then you shall like to apply quality in every sector of life, and that's where we can say quality life exists. It doesn't matter what money it is, it has no relation to money, it has relation to determination, it has relation to commitment. Money doesn't matter everywhere. You cannot say because I did not have money, I could not achieve quality. That is irrelevant statement. And engineers can handle it, and now I'm going to reliable coordination engineering projects. Now projects are done, everybody does projects, somebody does this project, that project, and there's no limit of that. Every engineer does projects, and many times we do many projects and we say, okay, I'm doing it's fine. And that project, every project is different, and that's true. Every project is different. We have to we have to understand that limit also. But project different doesn't mean that we can't understand anything. A project is different, but engineering is no different. Designs are no different. Of course, many whatever work we design, engineering is actually research work. If you say, even construction is always different. It's not design simply that varies even for same type of work to other type of work. Execution is also a kind of research because you have to provide all details, maybe particularly for foundations or we call a substructure. These are all different. For every building it's different. For every you can say other infrastructure project is different. Sewer line, water line, canal work, irrigation work we can say. And previously used to be a different type of welling in old days, in old times. And also you can say dams work, reservoir, we call it multi-purpose reservoir. Same way flyovers, bridges, and many more. Or you can say nuclear reactors, so airports construction, medical hospital construction. Likewise, whichever field you take, you shall find different type of requirements, different type of complexity, and different type of services to be installed. And services, the abundance of services. It's very important to technical on that. Technical coordination, engineering coordination, works coordination, design coordination, practical design, and of course coordination among everybody else. And that's a very complicated one, but so you cannot say that it's impossible because conflicts are there and complications and conflicts are required to be released, required to be deactivated. If you are able to solve clashes, then I think half of coordination is over. But we miss that. Why we miss that? Actually, we do not know. To be very frank, I have good experience in coordination, but I feel intellectually, I'm not saying I feel emotionally. I feel or I can logically state that coordination is not working in fact. I don't know why we people don't take interest. We just try to take, young people. If you compare previous young people, means people in 1970s, 80s, those people had different approach towards life. Communication, of course, communication was a burdensome in those days, but coordination, even without good communications, was good. People used to think on papers and not computers, and used excellent way, vibrated minds very rapidly, and that vibration provided them something different. But now it's not happening, and I'm really surprised. Even students, young students, school students, they're not active in calculations. Unfortunately, one may be in 9th standard, 10th standard, 12th standard, but they may be in standards, but not in real life standards. They may be in standards just to get up, just to exam get pass and go and say, I got it, I am passed, I am in 12th standard. But when you ask something in small calculation, these people cannot answer. They cannot use memory of mind for purpose of calculation. They look surprised. And that's what I say. Application of engineering means application of mind. Engineer cannot sit on calculator all time and say, I calculate first. If you cannot calculate anything, it means your mind is not developed, and that's very important point in engineering. You should have assessment. Even you depend on computers, but you should not exclusively depend on computers itself, because computer is not human being. It's just it's support to humans, support to professionals. It's not exactly what I say. So my questions remain same. Why questions are here for you? It is, you don't say why and how. These are requirements. If you don't raise these questions to yourself, you don't do justice to yourself. Remember, you have to do your job, your engineering job or non-engineering job, where coordination works everywhere. And is coordination engineering a must on every project? There should be no doubt. Yes, it is. Without that, it's not possible. You cannot find today project, oh, you have to do brickwork and some cover on that, it's called as a room. I go and stay. There's no toilet, there's no bathroom, there's no service. How can you see that? So I'm saying time changes, requirements change, and everything changes. And then we go to project means all performance activities involved. Yes, that's true. All performance activities are involved. Let me put off my battery. Project means all performance activities involved, from pre-designs to final completion of complete construction. That's true. We have to agree with this fact. We can't say no on this. We have to. Project means all performance activities involved, from pre-designs to final completion of complete construction. That's what's project. Initial pre-design to complete construction. And of course, few difficult questions which we have to answer. But that's regarding quality and coordination. Of course, there should be questions and answers are sought. Quality and coordination are domains, and we can say respective involvement in entirety. Respective involvement in entirety it is. Can we ignore these domains? And that's also a question. Can we ignore them? No, we cannot ignore them. That might be hard to understand. Can we ignore these domains? What do we engineers think over issues as mentioned about ignorance, about respective involvement of entirety of quality and coordination? And what do we think as issues as mentioned? How many of ourselves, how many of us do conduct works per quality and coordination engineering requirements? We know ourselves, so nobody shall have to tell us. We have to be self-examiner of our work. And once you think you are self-examiner, then you won't make mistakes intentionally, or you won't make mistakes even unknowingly. Because we have to respect material value, resources value, because in construction, of course it is little time consuming, but it's better not to waste material until we can say, yeah, I'm going to do the right job. Civil engineering is not manufacturing, in fact. It's call it manufacturing concrete, but civil engineering itself is not manufacturing. It can't go with speed. I think manufacturing goes on because there's automation in construction. Automation, very, very few, very, it doesn't work full time. Sometimes, concrete is automated. Okay, that's production. But laying can't be automatic, and every project is different, every design is different, every specification is different. And you can't say two buildings are same, even if they are same in superstructure. They may be different in foundations, or the soils may be different. At that point, we have to realize how many of us to conduct works for quality and coordination issue. Coordination, that's again a question mark. It's not time, right one. It's not right time to contemplate and deliberate on this subject. Can we have good industrial practice? Can we achieve it? When we achieve good industrial practice, and that's really very important point. Can we industrial good practice? Can we achieve that without moving through quality and coordination domains? And some people talked of cooperation. Of course, cooperation is a must. And that can't be called domain. Cooperation is cooperation. We have to cooperate with each other in different staffing levels, as in different branches or sub-subjects, or you can say domains, or whatever you can call it. Cooperation is a must at every level. And can engineering designs be reliably carried out? And that's only applicable on designer and on person who works on that. Without involving quality and coordination, yes, you have to define quality. Again I say, you have to define quality, and you have to direct that this work should be done duly coordinated. Without coordination itself is a part of design, and designers cannot deny this fact. coordination starts the design itself, otherwise you can't do design. Coordination itself is, and structure itself, there is coordination between concrete and steel. This point we have to understand. We cannot do this. A coordinated work, calculation, detailing is all coordinated work. If it's there in one same subject, same field, or RCC field, you can say priestess field, you can say structural steel, you can say there's coordination among itself. And coordination between same branch, other branch, or same discipline, other discipline, of course, very important, significant. What we are doing, and that's point. Often this is just for a few words. I will really say, of course, I could not give more details on these projects I do, but I just don't find time for that. What to do means we have to understand coordination. That's the important one, you can say. Actually, I thought in a different way, but it's happening as something else. So I can say here's coordination engineering is a must on every project, which the title is, and that is coordination engineering is a must on every project, and that point can't be defied. Every day something is important to be comfort with, and we have to understand the reality of this. And is that coordination engineering is a must on every project. Designs, construction, and controls are very solidly interrelated. Designs, construction, and controls are very absolutely interrelated, required sections for achieving from successful start to completion of a project, which all must be applicable throughout project stages, with all works be affected. And that's really wonderful point we have to think of. Designs, construction, and control are very solidly interrelated, required sections for achieving from successful start to completion of a project, which all must be applicable throughout project stages, with all works being smoothly effective. These sections or stages are initial conceptual designs, designing for works execution purposes, procedure implementations about how to chart out construction of designed project works, project construction works, currency decision, and works carrying out testing, completion, and commissioning, and launching use of project when project title terminates, renaming that title operation or occupancy in project. So this is what I say coordination engineering, which is, and we have to really understand how it works, what it is, and of course I can say that there is no answer to this. There is no you can say replacement of this. There is no replacement of coordination engineering. We can say that coordination engineering is a very important part. We can't otherwise move without this. Coordination engineering is something, it's not actually field of engineering, because it exists in every field of engineering, every branch of engineering, and not only in engineering field, it also applies to all other fields. Coordination means even in maintenance of railway system, you see which train is coming, which is going on same track, on different tracks. Or so much complication exists in railways itself, and if you don't coordinate properly, if signals do not coordinate properly, if personnel do not coordinate properly, or you can say it can result in accidents. And same with controls, coordination and controls. You can say in air work, in aeroplanes, this fly. You can say ATS is a control, traffic system, traffic control. Same way, control exists everywhere, and that's coordination. What should happen at what time? What should happen and what time we should know, And for that happening, what is required we should know, and at what time what is required that we should know. Though maybe it's documented or it's not documented, but we know that it has to be provided at that point. So it's kind of coordination. Even somebody is cooking in kitchen, you are cooking vegetable, you are cooking something else. This is also a method of that. Of course, you have to follow that method or you have to evolve your own method. It's up to you. But whatever you do, there is some sequential coordination without which even your cooking cannot work well. So you can say coordination engineering is not in field of engineering itself, but it exists everywhere, and you have to coordinate. Of course, it's of low level, not of that high level, but on engineering it exists as every level. And without coordination, these works cannot be done, which you have to do. That's point we should be very strong on that. Coordination is not a subject, that's true, and you can't find coordinators everywhere. It's not question of seniority or juniority, it's question of meeting requirement. When an engineer comes duly qualified after passing engineering education, I can't say that engineer is qualified for purpose of coordination. Okay, that engineer is qualified for purpose. The one has got complete education of degree engineering or even masters or sometimes even higher than that. That is fine, he has got good level of education. But you can say an earning experience is extremely important for every new engineer, because you are a theoretical engineer. Even though you might have done some project, doesn't mean you have become an engineer. Theoretically you are fine, but you can say real world is work, production, what you want, and that is an art, or that's a science, or that's, you can say, expertise. You have to do that work which you learn theoretically into physical world, into practice. How far you can do that, how much you can do that, consideration in considering quality and quantity, how much you can do that's important. Education certificate is something different than real certificate. Okay, you had syllabus, you had examiners, you had teachers, you had everybody. There were so many people to guide you, and they all brought you to this level that you have been able to understand all program. But that does not mean you have understood prosecution. You have understood everything. And coordination is that domain where you have to depend upon. Either you control yourself or coordination shall impact on your work. Designs must be coordinated, planning must be coordinated, and all works must be coordinated. Whatever method statements we produce must be duly coordinated. Whatever questions we raise to be coordinated. We must have studied total project documents, total project designs from viewpoint of doing it, which we can say it is called constructability or constructional, you can say construction program. That there should not be anything in that which we say, oh, I can't do it, how it is. If I can't do it, there is some problem, maybe material problem, some other problem, then we should have another parallel program for that, how to handle that, which we can call alternative submission, alternative method, or alternate method, or parallel method, not mandatory, that's the mandate. That's why I said the designs coordinate, designs, construction, controls are very absolutely interrelated, required sections for achieving from successful start to completion of a project, which all must be applicable throughout project stages, with all works be smoothly affected. These sections or stages are initial conceptual designs, designing for works execution purposes. Designing for works execution purposes means initial design is different, initial design of project is different, But when do it, that's also required to design of how to do it. Procedure implementation, you can say procedure implementations about how to chart out construction of design project works. Then you can say project construction works, currency decision and works, all that. Carrying out testing, completion, commissioning and launching. All these are very important points. Here we have to consider. We can't get rid of these without doing that. So, like say, these sections or stages are initially conceptual designs and designing, and also we say you have to do it, and that's also called design. How to do it, how to plan it, how to works on all these requirements of doing, planning, scheduling, quality, method, construction, quantification, quality handling, all these, testing, completion, electrical, mechanical, civil, or decoration, or whatever else. So much is involved. We should not be worried about that, but that's the different domain. Design part, construction part, planning part, quality part. Of course, every part is specialized. It's not academically, it's specialized practically. It's specialized work-wise. So we must be sure about that. You may say my design is safe or oversafe or is past one, but real construction involves expenses. Real construction involves materials, resources, times, everything, and use of that project. So that is different world. Design cannot be done if it is not worth, if it's not professionally done. I don't want to mean that you should do extraordinary design, but we have to design. Design should be done keeping in view ease of construction, best construction with best quality. And that's point we have to see. Difficulties on works which are expected must be anticipated by designers. Designer doesn't mean pure designer. Designer must have experience, or if one does not have experience, then one has to consult those who have such experience. Just like site people or works people consult experts in capacity as consultants. These site people work is checked. It's also kind of consultancy, you can say. You call consultant, have check on this, examine, approve this one. That's also kind of consultancy. The consultant makes sure, along with site person, that this work is approved. Approved means I have seen this and I find there's no problem in this. Approval doesn't mean that it's authority or it's liability or it's something else. This means, okay, I have made sure this person has worked and this person has worked according to requirement, and that's just a kind of authentication that yes, we have seen this. But the responsibility lies with person who did it again. Remember, consultant got no responsibility as far as liability is concerned. So we can say objective of that's what I'm saying. Now I don't want to go much more than that. Now we go to specification. I'll come back to this issue. Specification, I hope I can say there's on some page, I think 150 or something, I don't know exactly how to say it. It was target performance of concrete. We discuss, define target and the determination of mixed requirement, select materials and determine provisional proportions. We had gone through. Then we had gone through the target performance of concrete. Let's say what is target performance of concrete, defining target performance. Maybe if you have studied last time, no problem, we can review this. target performance on basis of characteristics value, on basis of characteristic values and reference values for concrete indicated in design specifications, workability, specified strength and durability, suitable for environment, you can say suitable for environment conditions, construction requirements and materials used are defined as target performance of concrete. It says on basis of characteristic values and on basis of characteristics values and reference values for concrete indicated in design specifications, workability, specified strength and durability, suitable for environment conditions, construction requirements and materials used are defined as target performance of concrete. Commentary says target performance of concrete to be taken into consideration in mixed design consists target performance of concrete to be taken into consideration in mixed design consists of workability, specified strength, durability. We discussed this last time. Mixed design is a series of tasks performed to specify concrete ingredients and their mixed proportions reflect actual environment conditions, construction requirements and characteristics of materials used on basis of reference values indicated in design drawings and specifications determined so as to achieve target performance of concrete. Concrete ingredients and mixed proportions are determined, and concrete performance verification process by trial mix method is repeated until performance requirement of concrete is met. In mixed design, upper and lower limits of ranges parameters such as slump, water cement ratio, water content and cement content are specified as mix requirements so that workability, specified strength and durability requirements are met. Commonly used indicators of concrete durability include carbonation rate. We discussed so I have defined this again. Read it for reference. Durability is specified in accordance with section 2.5 of says, and that's appropriate mix requirements and materials to be used are determined on basis of durability related reference values indicated in design drawings and specifications so that required durability against carbonation, chloride attack and freeze thaw cycle can be achieved. 3 points: carbonation, chloride attack and freeze thaw cycles can be achieved. If reference values indicated in design drawings and specifications are not used as reference, either past mixed proportions data or other reliable data are used as reference, or appropriate mix requirements are determined after conducting tests in advance and ascertaining that characteristic values indicated in design drawings and mixed design, these requirements are specified so that Required durability can be achieved against chemical attack and in mixing water cement ratio we have gone through, and we had gone through. There are some mixed requirements we have gone through. We have gone through these slump values. I'm just trying to tell you what we had done before. This we had done, and of course we have to go to typical values of minimum slump we have gone through. I'm just trying to find means for something refreshing. Then we have gone through all this, and now we have to say we have gone through this also, flow chart for slump determination at different stages. And here is what we say. Here is, we'll go to this also we have gone through. Remember all these points we have gone through. Changes slump over time, gone through. Standard construction methods, of course we have gone through this. We have gone through this compaction height as well, and we say example of construction height that you have seen means from where we stand on the platform down to where concrete is, new layer of concrete is, and also previous layer we have to consider. It is more design factor there. Okay, we have not gone through this, so let's be back here and think of how to do it. Now required strength, here this we have gone through, this we have already gone through. Let us see this part, something to remember. Let us repeat this. In construction standards, compaction height, which is related to degree of ease or difficulty of compaction, and placing height, which is a widely used term. There's compaction placing height distinguished. Compaction height is defined as height from working platform on which construction workers stand to lower end of formwork, upper surface of previously cast concrete layer. If concrete is placed continuously and compaction is performed while moving upward as height of newly placed concrete increases, distance from moved working platform to the surface of previously placed concrete is compaction distance. So let us repeat. If concrete is placed continuously and compaction is performed while moving upward as height of newly placed concrete increases, height of newly placed means fresh concrete increases, distance from moved working platform to surface of previously placed concrete is compaction. It is called previously placed concrete, and this is compaction height. Same way, this is compaction height, and same way this is compaction height. So we can understand what is compaction height. Minimum slump or placement. Minimum slump placement is determined for each type of member. We know that. Use of different types of concrete mixes with different slumps. However, when different types of members such as columns, beams, walls, and slabs are cast continuously to make construction work and organization of it cumbersome and lower construction efficiency. A rational approach in such cases is to select concrete mixes suitable for members that are relatively difficult to construct and require relatively large minimum slump. It's important, however, to carefully consider in advance whether problems can be prevented by modifying concreting related arrangements such as concrete placement in order to keep performance of fresh concrete necessary for placement. It is necessary to predict changes in concrete quality due to influence of pumping conditions and environmental temperature, and allow for such changes in determining slump requirements. Typical changes in slump corresponding to different construction conditions, such as pumping conditions. If relevant information such as past construction records and pumping tests result is available, slump requirements should be determined on basis of such information. We have to think of required strength. Required strength of concrete is determined of specified strength. What is specified strength? And they can say what is required strength. Specified strength and required strength. So required is higher than the specified strength. It should be according to common sense. Required strength, that is F-CR of concrete, is determined so that probability measured value of compressive strength of concrete obtained as on site test result is smaller than specified strength, is 5% or less. Required strength F-CR of concrete is determined so that probability that a measured value of compressive strength of concrete obtained is an on-site test results is smaller than specified strength is 5% or less. What's commentary here? Quality of concrete, usually quality of concrete at a construction site varies during construction period depending on such factors as changes in quality of aggregate, cement, etc. There can be changes, and of course these are measuring errors, you can say, and changes in way concrete ingredients are mixed. Required strength of concrete, therefore, needs to be made higher than specified strength. This is what I said. Required strength of concrete, therefore, needs or requires to be made higher than specified strength according to variability of concrete quality at construction site. In order to ensure that the compressive strength of concrete in whatever part of structure is not lower than compressive strength assumed when designing structure. Required strength of concrete needed relative to specified strength is usually determined in accordance with conditions. Now, what are these conditions? Describes compressive strength. This clause describes compressive strength requirements. This clause describes compressive strength requirements for test specimens to be used to achieve specified strength of concrete. Inevitably, measured values of compressive strength of concrete vary to some extent depending on changes in quality of cement, aggregate, etc. Measuring errors, differences in conditions under which mixing and other tasks are performed, test errors, etc. I repeat this a few conditions. You have to know the common sense based conditions, there's not very specific one. Says this provision describes compressive strength requirements for test specimen to be used to achieve specified strength in concrete. Inevitably measured values, compressive strength of concrete vary to some extent depending on changes in quality of cement, use different quality of cement, so there's an affect strength. Aggregate also different effect. Measuring error can be there, difference in conditions under which mixing and other tasks are performed, there can be impact on that. Test errors, of course. It's known from experience the variations in compressive strength of concrete under ordinary quality control conditions are more or less distributed normally. Assuming a stochastic distribution, assuming stochastic, is known from experience as assuming a stochastic distribution Stochastic distribution. Everybody shall like to know what is the stochastic. Everybody cannot understand that. And that's fine. We have to say how to explain in Hindi. That's the problem. Stochastic. Stochastic meaning. Stochastic technique is having a random probability distribution or pattern that may be analyzed statistically but may not be predicted precisely. Stochastic definition. This is from refers to property of being well described by a random probability distribution line. That's topic testimony. Let me say. I think the kitab is more explanatory, so I should refer to that one. It says it's a Greek. It's one stochastic. It refers to property of being well described by random probability distribution. Although stochastically and randomness are distinct in that former refers to stochastic refers to modeling approach and later refers to phenomena and that's randomness. These two terms are often synonymous. Furthermore, in probability theory, formal concept of a stochastic process is also referred to as random process. Stochastically is used in many different fields, including natural sciences such as biology, chemistry, ecology, neuroscience, physics, as well as technology and engineering fields such as image processing, signal processing, information theory, computer science, cryptography, and telecommunications. It's also used in finance due to seemingly random changes in financial markets, as well as in medicine, linguistic, music, media, color theory, botany, manufacturing, and geomorphology. So stochastic modeling is also used as social science. That's what says stochastically. Word stochastic in English was originally used as an adjective with definition pertaining to conjuncturing, and stemming from Greek word meaning to aimed at a mark, guess, and Oxford Dictionary. So mathematics, I'll leave it now. This is further definitions. I'm not interested in that. So we understand what is stochastically, and that's why it's important. Meaning is understood. So is that stochastically we can say that one. We are assuming a stochastic distribution. Therefore, this guideline requires probability, that's measured value of compressive strength of concrete used for an ordinary structure is smaller than specified strength by 5% or less. A measured value of compressive strength of concrete obtained as an on-site test result is average value of compressive strength obtained through standard curing of 3 concrete specimen. Strength is smaller than specified strength, is not higher than a predetermined percentage. It's necessary to select a strength value obtained by increasing specified strength appropriately according to variation in measured value of compressive strength as required strength. It says in order to ensure that probability that the measured value of compressive strength is smaller than specified strength, is not higher than predetermined percentage, it's necessary to select a strength value obtained by increasing specified strength appropriately. Required strength. The figure shows a relationship between coefficient of variation and over-design factor in cases in which predetermined percentage mentioned about 5 only. A recommended standard procedure is to determine over-design factor corresponding to coefficient of variation In compressive strength of concrete at construction site from figure mentioned above, after which over design factor and specified strength of an appropriate value are selected, and it should not be smaller than required strength of that structure. In case of concrete to be used for very important structure, this predetermined percentage should be reduced to a smaller value, and another over design factor determined from that percentage and coefficient of variation in compressive strength should be used. As said, as mentioned before above, in order to determine required strength of concrete, it is necessary to find out coefficient of variation of measured compressive strengths of concrete at construction site and determine over design factor accordingly. This value should be determined by past experience, equipment at construction site, variations in quality of material used, skill level of construction workers, etc. These are factors. This value should be determined. That is, what is factor, what is an factor, and what is compressive strength on site. This value should be determined by past experience, equipment at construction site, past experience, you can say equipment at the site, variations in quality of materials used, skills, levels of construction workers. At early stages of construction, however, it's not uncommon that it is difficult to estimate coefficient of variation appropriately because there exists dearth of information on equipment at construction site, variations in quality of materials, etc. An appropriate method to be used in such cases is to determine required strength by using somewhat larger over design factor. After concrete work is started, required strength can be modified according to actual coefficient of variation. Now is the over design factor in normal case, and there's to here you can say expected coefficient variation in compressive strength, that is V percentage wise. Expected variation, this V is very compressive strength, and over design factor A. Here it goes 5, 10, 15, 20, 25 is in percentage, and this is in coefficient alpha. It's given alpha value, and its equation is 1. This is 1 divided by 1 minus 1.645 V is percentage here. So 1 minus of V over 100. This is a bracket. So if you got values between 1 to 1 plus A, here for example you got alpha is less than 1.1, here maybe it is 1.2, here alpha is somewhere 1.33, and here is somewhere likewise it goes here 1.7. So expected coefficient variation compressive strength is like that. This is over design factor depending on variation in compressive strength. So as I said, variation in compressive strength and alpha factor. So more variation in percentages, more alpha factors. That might be hard to understand. Alpha here, alpha means here. What's alpha? It says maybe says here or something. And let us say equation is 1 divided by some coefficient, and which would be 1 minus 1.645 percentage. Let's say the 2 percentage, what it should be. Well, let's example of 1.645 into 2. So 1.645 into 1.645 into 2 over 100 into 2 over 100. So 3 is 3.3 something over 100 is 0.33. So 1 minus that. So it's less than 1. In fact, this figure should be less than 1. And of course it should be more. So it should be minimum of 1. Let's say 1.0. For example, there is no variation. So it's 1. If you say 645 to 0, there's 0% variation. This means it is simply it is 1. Answer is 1. If it say it is 1% variation, then we can say 1.645. 1 minus, that's the margin, so it's something like that. So we have to calculated it accordingly, and you can say that this is, it does generally the 5%. Let's say there's some more variation. More variation means more value of this and more lesser than 1, so factor would increase, right? 7. Let's say there's 25% variation. In 25% variation, it is saying that it is alpha is equal to 1.7. If it's 20% variation, it's saying 20% variation here, it is saying alpha is about less than 1.5. And if it's saying 15% variation, and it's 1.33 something. And it's 10% variation, it's 1.2. So here is, you can say if it's 5% variation is 1.1. And if it's no variation, you can say, so that's what I say, water cement ratio. Water cement ratio, which is, you know very well, is a very important part of engineering, particularly concrete. It's very, very important part. This water cement ratio, water cement metal ratio, is determined by selecting smallest value determined in view of strength, durability, water tightness, cracking resistance, and steel protection. We have already studied this. That's why water cement is determined based. Water cement ratio is determined by selecting smallest value determined in view of strength, durability, water tightness, cracking resistance, and steel protection. Performance required of concrete on basis of reference values indicated in design specifications. When water cement ratio is determined on basis of compressive strength of concrete, it is determined as follows. So how to determine? Let's see. Compressive strength of concrete, how to determine that? Procedure as a general rule or relationship between compressive strength and water cement ratio shall be determined experimentally. Testing age is 28 days, we all know as the standard. Other testing ages, however, may be used depending on type of cement to be used. If higher strength cement is used, or if low heat cement is used for purpose of thermal stress control. Water cement ratio to be used for mixed proportion. Water cement ratio to be mixed proportion shall be reciprocal of cement water ratio. Water cement ratio shall be, water cement to be used for mixed proportion shall be reciprocal of cement water ratio corresponding to required strength. F-CR in relationship between cement water ratio PW and compressive strength F-CN reference age. In cases where water cement ratio is determined in view of durability of concrete, in cases where water cement ratio is determined in view of durability of concrete against carbonation, chloride attack, and freeze-thaw cycles, water cement ratio is determined so that it's not greater than reference value indicated in design specifications. In cases where water cement ratio is determined in view of durability of concrete against chemical attack, water cement ratio should be determined on basis of given table. See water cement ratio in case where water tightness is taken into account should be set at 55% or less as standard. Water cement ratio to be used shall be smallest among water cement ratios determined from required strength, durability, water tightness, cracking resistance, and steel protection performance of concrete. Again I say, water cement ratio to be used shall be smallest among water cement ratios determined from required strength, durability, water tightness, cracking resistance, and steel protection performance of concrete. Under normal conditions, water cement ratio determined taking these factors into account rarely exceeds 65% of 0.65, that is, since however can say many problems encountered in past occurred in structures while built. Many problems encountered in past occurred in structures built with concrete with a water cement ratio exceeding 65%. It says, however, many of problems encountered in past occurred in structures built with concrete with a water cement ratio exceeding 65%. It's a basic rule to specify a water cement ratio of 65% or less when determining water cement ratio for concrete to be used for offshore structures. Offshore is the construction, special concretes. Now, let's say, leave that. Water cement ratio is to be determined on basis of reference values. On basis of reference values indicated in design specifications. Water cement ratio to be determined on basis of reference values indicated in design specifications such as upper and lower limits or range of water cement ratio, cement content and type of cement. If it is judged that these values and ranges are not adequate because of quality of material to be used, system for supplying materials or other factors, it is necessary to select an appropriate realistic value after ascertaining that characteristic value requirements specified in design specifications are met. Fact that cement water ratio and compressive strength, that's F-C, fact that cement water ratio and compressive strength are linearly related within a certain range can be used to determine relationship between compressive strength of concrete and water cement ratio. In universal linear formula applicable to either type of material, however, has not yet been derived for determining relationship between cement water ratio and compressive strength. As a general rule, therefore, this specification requires that relationship between compressive strength of concrete and its cement water ratio be determined experimentally. So what we do? Cement water ratio to strength relationship is determined as follows. 3 or more types of concrete mixes with different cement water ratio are listed or tested within a range that is deemed appropriate to derive cement water FC curve. In case of air entrained concrete, test specimens are prepared by using concrete strength. What we are deciding actually here is cement water factor, cement water ratio, and water cement ratio we are defining now. Water cement ratio says, as it says in this paragraph, water cement ratio is to be determined on basis of reference value indicated in design specifications such as upper and lower limits, range of water cement ratio, cement content and type of cement. If it's just that these values and ranges are not adequate because of quality of material to be used, cement for supplying materials, system for supplying materials or other factors, it's necessary to select an appropriate realistic value after ascertaining that characteristic value requirements specified in design specs are met. Fact that cement water ratio and compressive strength are linearly related within certain range can be used to determine relationship between compressive strength and water cement ratio. Compressive strength and water cement ratio. A universal linear formula applicable to whatever type of material, however, has not been derived yet for determining relationship between cement water ratio and compressive strength. As general rule, therefore, this specification requires the relationship between compressive strength of concrete and cement water ratio. And what you do, 3 more types of concrete mixes with different cement water ratios are tested within range that is deemed appropriate to derive the curves. In case of air entrained concrete, test specimens are prepared by using concrete mixes with required air content. In order to minimize errors in mixed tests, my battery is now 45%. In order to minimize errors in mixed tests, you can say average value for specimens prepared from two or more batches of concrete should be used as value of FTS for each cement water ratio. If mineral admixture that can be expected to act as a binder, such as ground granulated blast furnace slag or fly ash, is used, numerator of cement water ratio may be taken as sum of mass of cement and mass of admixture. In case of air and concrete, relationship between this ratio and strength varies depending on air content. If air content remains constant, relationship between CW and FSC can be approximated by a linear equation. In cases where specified strength age is not 28 days and where mixed proportions require be determined early, 28 days strength and relationship with strength at that age is known, water cement ratio may be determined by using a reference age other than 28 days. And I say in the case where specified strength age is not 28 days and where mixed proportions need be determined early, and 28 days strength and relationship with strength at that age is known, water cement ratio may be determined by using a reference age other than 28 days. If relationship between cement water ratio and compressive strength at age of 28 days has been fully ascertained, above mentioned, this is in the downscale of omitted. If homogeneous concrete is to be made, it is necessary to use homogeneous materials, measure them accurately, and mix them sufficiently. Even if these tasks are performed, however, variation in quality of concrete is inevitable. Even if these tasks are performed, however, variation in quality of concrete is inevitable. In order to ensure level of safety considered at structural design stage, therefore it is necessary to determine a required strength value by increasing specified strength according to variations as a compressive strength value. So I say, if homogeneous concrete is to be made, it is necessary to use homogeneous materials, measure them. Let me see battery please. 41%. If homogeneous concrete is to be made, it is necessary to use homogeneous materials, measure them accurately and mix them sufficiently. Even if these tasks are performed, however, variation in quality of concrete is inevitable. In order to ensure level of safety considered at structural design stage, it is necessary to determine required strength value by increasing specified strength according to variation as a compressive strength value needed when relationship between cement water ratio and compressive strength mentioned. In cases where durability of concrete against carbonation, in cases where durability of concrete against carbonation chloride attack, and freeze-thaw cycle must be taken into account for design purposes. Verification is made as described in design general requirements of this specific and necessary uplift limit of water cement ratio is indicated in design specifications as reference value. And necessary therefore to determine water cement ratio so that value is not exceeded. When a high range quality mineral admixture is used appropriately, denominator of water cement ratio needed from the viewpoint of durability may be taken as sum of mass of cement and mass of admixture. When coming into contact with soil or water containing a substantial quantity of sulfate, concrete is eroded by chemical reaction. Aim of this clause is to ensure that strong and voidless concrete that is highly durable against such chemical reaction can be obtained. When coming into contact with soil or water containing a substantial quantity of sulfate, concrete is eroded by chemical reaction. Aim of this clause is to ensure that strong and voidless concrete that is highly durable against such chemical reaction can be obtained. Air content in air entrained concrete. Air content in air entrained concrete. Air content in air entrained concrete should be 4 to 7% of concrete volume. Air content in air entrained concrete should be 4 to 7% of concrete volume, depending on maximum size of coarse aggregate and other conditions. Air content test for concrete shall be conducted in accordance with this commentary on this. Concrete with an appropriate amount of air entrained content is highly durable. Concrete with an appropriate amount of entrained concrete antimatter is highly durable against freeze thaw cycles. As a general rule, therefore, air entrained concrete shall be used in cases where concrete is to be subject to severe weather conditions. Common practice is to specify a standard air content of about 4 to 7% of concrete volume upon completion of mixing. Air content during production process shall be determined in view of time dependent changes during process from production to placement and changes during transportation. Entraining air is highly effective in improving workability of concrete. But using air entrained concrete, therefore, water content needed achieve required level of workability can be reduced substantially. Strength of concrete, however, decreases as air content increases. Strength of concrete, however, decreases as air content increases. And variability of concrete quality tends to increase as air content increases. Advisable is therefore not to increase air content excessively if weather conditions are not severe. Air content of air entrained concrete varies considerably depending depending on various conditions. Air content of air-entrained concrete varies considerably depending on various conditions. Even if air-entrained agent content remains unchanged, an air content test shall be conducted, therefore, prior to placing air-entrained concrete. Air content test may be conducted. Now, determination of provisional mix proportion. Water content. Determination of provisional mix proportions. Water content. Water content is determined experimentally and be made as low as possible to extent that concreting task can be performed. Water content is determined experimentally and be made as low as possible to extent that concreting tasks can be performed. Upper limit of water content of concrete should be 175 kg per cubic meter. That's everywhere, upper limit. If water content exceeds this upper limit, it shall be ascertained that required durability is attained. Water content is determined experimentally and be made as low as possible to extend that concreting task can be performed. Upper limit of water content concrete should be 175 kg per meter cube as a standard. If water content exceeds this limit, it shall be certain that required durability is attained. A higher water content tends to result in degradation of quality of concrete, such as degradation in segregation resistance. Let's say degradation in segregation resistance and an increase in drying shearing case. It is therefore necessary to make water content as low as possible to extent that concreting tasks can be performed. Because water content of concrete required to achieve required slump differs depending on such conditions as maximum size of coarse aggregate, particle size distribution, and particle shape of aggregate, type of admixture, and air content of concrete. Type of admixture and air content of concrete. This specification requires that water content be determined through trial mixing by use of materials to be actually used for construction. Water content can be reduced considerably by making appropriate use of air entraining agents. Air entraining, water reducing agents, superplasticizers, etc. Water content can be reduced considerably by making appropriate use of air entraining agents. Air entraining, water reducing agents, superplasticizer, etc. Percentage of water reduction, which varies depending on air content, type of admixture, concrete mix, proportions, etc. is about 6 to 10% for air entering agents. So percent of water reduction, which varies depending on air content, type of admixture, concrete mix, proportions, etc. is about 6 to 10%. That is percentage of water reduction, which varies depending on air content, type of admixture, concrete mixture is about 6 to 10% for air entering agents. that is reduction of water quantity by 6 to 10%. Chemical admixture for concrete, 10 to 14% for standard type or retarded type air entering water reducing agents, 8 to 10%, 12% for accelerator type agents, and 16 to 20% for superplasticizer. Water content in case where crust stone or blast furnaces like those aggregates use about 10% higher than in cases where gravel is used, although it varies differently depending on shape of particles. So this is very important provision. I have to be clear about this. Says water water content can be reduced considerably by making appropriate use of air entering agents. Air entering water reducing agents, superplasticizers, etc. Percentage of water reduction, which varies depending on air and air content, type of admixture, concrete mix proportions, etc. It's about 6 to 10% for air entering agents. Chemical admixtures for concrete, if you do that, then 10 to 12%, 10 to 14%. That's 6 to 10% because of its concrete portion, and that is chemical admixture 10 to 14%, and standard type of retarder type air entering water reducing agent 8 to 12% for accelerator type agents, and 16 to 20% for superplasticizer. Water content in case where crushed stone is used, although crushed stone blast for a slag course aggregate is used, about 10% higher than in case where gravel is used, although it varies depending on shape of particle. Because water content greatly affects quality and durability of concrete, this specification requires that water content be specified at or below upper limit of 175 kg per cubic meter as a standard. In this specification, water content of concrete refers to water content specified at mixed design stage. It doesn't mean, therefore, that upper limit of water content reflecting quality variation in actual construction work is 175. If water content of concrete containing an air entering water reducing agent exceeds 175 kg per cubic meter, a superplasticizer instead of an ordinary air entering water reducing agent should be used so that water content becomes 175 kg per cubic meter or less. In case of plain concrete, however, in case where it can be ascertained that durability of concrete will not adversely affected water content higher than 175 kg per cubic meter may be allowed. Lower value of water content is not specified, but water content should be 145 kg per cubic meter, higher when using crushed stone or crushed sand. Shows recommended ranges of water content. If water content of ordinary concrete deviates from ranges shown, appropriate actions such as using a high performance water reducing admixture such as Air entering water reducing agent or super plasticizer should be taken in case of concrete whose fluidity is evaluated in terms of slump flow, such as fluidity high fluidity concrete. Lower limit of water content is not specified, but the water content should be 145 kg per cubic meter or higher when using crushed stone or crushed sand. Shows recommended ranges of water content. If water content of ordinary concrete deviates from ranges, appropriate actions such as using a high performance water reducing admixture such as an air entering water reducing agent or super plasticizer should be taken. In case of concrete whose fluidity is evaluated in terms of slump flow, such as high fluidity concrete, 2 water content should be determined with reference to ranges. Recommended ranges of water content for concrete, let us say maximum size of aggregate is 20 to 25, this is 155 to 175 kg per cubic meter, and that's 40 is 145 to 165. Cement content shall be determined on basis of reference values indicated in design specifications. If a number upper or lower limit is specified for cement content, that specification shall be met. Cement content shall be determined on basis of reference values indicated in design drawings and specifications. If an upper or lower limit is specified for cement content, it shall be ascertained that cement content determined from water content and water cement ratio falls below upper and lower limit. It shall be ascertained that cement content determined from water's content and water cement ratio falls between upper and lower limit specified for water content. It doesn't fall within range between upper and lower limits. It's necessary to change material used for mixed design, mixed proportion. In case of concrete made by using a super plasticizer, and if cement content is too small, it tends to result in poor workability and degrading in lump sum or it's recommended if it's necessary to change material use, it doesn't fall within range between upper and lower limits, it's necessary to change material use for or mixed proportion. In case of concrete made by using a super plasticizer, and if its cement content is too small, it tends to result in poor workability and degradation on slump. Over time increases. It's recommended therefore that its maximum size of coarse aggregate is 20 to 25 mm, cement content of at least 270 kg or 250 kg per meter cube. Maximum size of coarse aggregate is 40 mm and preferably 300 kg per meter cube or more scaled. By increasing cement content, cracking due to hydration of cement may cause problem. To solve this problem, chemically inactive powders such as limestone powder can be applied in case of mass concrete, which is subject to cracking due to hydration of cement. If It's necessary in increase cement content. Cracking due to hydration cement may cause problem. To solve this issue, chemically inactive powder such as limestone powder can be applied. In case of mass concrete, which is subject to cracking due to hydration of cement, it is necessary to determine an appropriate cement content with reference to mass concrete. If cement content does not fall within upper and lower limits indicated in design specifications, or if type of cement is to be used as changed, verification requires be conduct against concerning cracking due to hydration of cement. Cement content of shear of concrete and water concrete shall be determined. Offshore concrete as stipulated constructions of powdery material we know as powdery material content. Powdery material content is determined so that segregation resistance appropriate for slump can be attained. Segregation resistance can be attained. Yeah, powdery powdery content contents of powdery material content is determined so that segregation resistance appropriate to slump can be attained. Powdery metal content is determined within range appropriate for pumping and placement. If a lower or upper limit is specified for powdery material content, all of such specifications shall be met. We have to read this little in details because it's of course important. In a couple of minutes I'll be back. Within that period you can read this. It's good to understand. I'll just take a few minutes to come back. Okay, just for mind. my dear friends, commentary is about that. We are talking about commentary in this case. We are talking about commentary about powder material contents, and that's very important one. Commentary about this powder, and that powder is what we have to understand what is that, and it's really important one to understand that, and we are going to understand that. Powder is a collective term for whatever material. Powder is a collective term for whatever material with a fineness equivalent. It's a collective term for whatever material with a fineness equivalent or higher than that of cement, including not only cement but also blast furnace slag, fly ash, silica, fume, and limestone powder. Limestone powder. Powdery material content is sum of content of those powdery materials, and powder content is a primary mix design factor affecting segregation resistance of concrete. If only cement, blended cement is used, powder content is same as cement content. Concrete ingredients are prone to segregation. It's indeed true. Concrete ingredients are prone to segregation if a powder content appropriate for slump is not secured. Concrete ingredients are prone to segregation if a powder content appropriate for slump is not secured. And an inappropriate powder content may result in defects at construction stage. An inappropriate powder content may result in defects at construction stage, such as honeycomb and incomplete filling. In order to achieve excellent pumpability and placeability, it is recommended that a powder content of at least 270 kg per meter cube be capped. If maximum size of coarse aggregate is 20 to 25 mm, at least 250 kg per cubic meter if maximum size of coarse aggregate is 40 mm, and preferably a powder content of 300 kg per meter cube or more is secured in order to ensure construction safety. Fine grains contained in aggregate are not taken into consideration here. Fine grains contained in aggregate are not taken into consideration here. An excessively high fine grain content of aggregate, an excessively high fine grain content of aggregate, however, may result in excessively viscosity of concrete. An excessively high fine grain content of aggregate, however, may result in excessive viscosity of concrete, so that workability declines. If therefore is fine grain content of aggregate is to be used, is a high fine grain content of aggregate to be used as high, powder content is reduced as needed basis. It is recommended in determining rough level of powder content. It is recommended when determining a rough level of powder content appropriate for specified slump. Can say mixed design. In order to perform smooth clogging free pumping, it is necessary to keep powder content at or above a certain level. If design specification indicates an upper If design specifications indicate an upper or lower limit of cement content, it is necessary to compare that upper or lower limit with powder contents determined. and determine powder content so that both requirements are met. It's just that it is recommended when if design specifications indicate an upper or lower limit of cement content, it is necessary to compare that upper or lower limit with powder contents determined as described in and determine powder contents so that both requirements are met. If it's just that meeting both requirements is not possible, material mix should be changed. Sand aggregate ratio. Sand aggregate ratio. Sand aggregate ratio. Sand aggregate ratio is determined experimentally so that water content can be made as small as possible to extent required workability can be attained. Sand aggregate ratio is determined experimentally so that water content can be made as small as possible to extent required workability can be attained. In mixed design of concrete, an appropriate sand percentage shall be selected. As sand aggregate ratio is reduced, water content needed to obtain concrete with required slump tends to decrease. Says as sand aggregate ratio is reduced, water content needed to obtain concrete with required slump tends to decrease so that cement content decreases accordingly and mix proportions become more economical. If sand percentage is reduced excessively, resultant concrete may tend towards segregation, so it may cause poor workability of concrete. For a given combination of fine aggregate and coarse aggregate, an optimum sand percentage solid that provides required workability. There exists an optimum sand percentage that provides required workability and minimizes water content. Because this sand percentage varies depending on particle size, distribution of fine aggregate, air content of concrete, cement content, type of mineral admixture, sand percentage needs be determined so that water content is minimized. It shall be kept in mind that sand percentage is percentage by absolute volume, not by mass of fine aggregate in total amount of aggregate in concrete. Particle size distribution of aggregate particle size distribution of aggregate should remain stable throughout construction period. If fineness modulus has deviated by 0.2 or more from that of fine aggregate actually used for mixed proportion during construction, workability is also affected considerably. In such cases, mixed proportions need be modified. On such occasions, validity of sand percentage values should also be verified by testing. In case of concrete pumping, it's necessary to select an appropriate sand percentage on basis of available data and past construction data. According to concrete pump performance, piping, pumping distance, etc. If superplasticized concrete is used, sand percentage need be determined taking into account workability of superplasticized concrete. In case of concrete containing a superplasticizer, a satisfactory result can often be obtained by using a sand percentage that is 1 to 2% higher than that of concrete that contains an ordinary air containing water reducing agent and the same water cement ratio and slump. Percentage of fine aggregate and coarse aggregate may be determined on basis of unit mass of coarse aggregate instead of sand percentage as mentioned above. If slump is large, relationship between sand percentage and workability tends to become unclear. There are cases, therefore, where appropriate mixed proportions can be better selected by determining unit mass of coarse aggregate first. By using this method, in case of plastic concrete, bulk volume of coarse aggregate per cubic meter of concrete, unit bulk volume of coarse aggregate can be made nearly constant, regardless of slump and water cement ratio, according to maximum size of coarse aggregate and particle size distribution of fine aggregate, so that coarse aggregate content can be determined easily even when using angular aggregates such as crushed stone. कुछ नहीं होगा, हेजिटेट करूँ तो कुछ फ़ायदा नहीं होगा, हेजिटेट नहीं करूँ उससे. Now there is a table that shows typical values of unit bulk volume of coarse aggregate, sand percentage and water content for concrete with water cement ratio of about 55% and a slump of about 8 cm. When air intent concrete is used in ordinary reinforced concrete construction, a concrete mix obtained from unit bulk volume of coarse aggregate tends to contain a somewhat higher percentage of sand. These values of unit bulk volume of coarse aggregate, sand percentage and water content for concrete with a water cement ratio of about 45% and slump of 8 cm. When air intent concrete is used in ordinary Reinforced concrete construction. A concrete mix obtained from unit bulk volume of coarse aggregate tends to contain a somewhat higher percentage of sand. Concrete mix obtained from unit bulk volume of coarse aggregate tends to contain a somewhat higher percentage of sand, and approximate amounts of correction for sand percentage and water content in cases where materials used and concrete quality shown. In general, as sand percentage decreases and coarse aggregate content increases, workability of concrete's pumpability and wide penetrating ability decreases. This means if you increase quantity of aggregate, coarse aggregate, pumpability and wide penetrating ability, you can say decreases wide penetrating ability. So you can say in workability of concrete, such as pumpability and wide penetrating ability decreases. It's necessary therefore to select appropriate minimum values of sand percentage and appropriate maximum values of coarse aggregate content appropriate for specified slums. When determining a sand percentage or coarse aggregate content appropriate for a slum, and we can say complete this. All appropriation, approximate values of unit bulk volume of coarse aggregate, sand percentage and water content of concrete. This is a big table. Here it says maximum size of coarse aggregate. Maximum size of coarse aggregate, and it's given 15, 20, 25, 40 mm. Unit bulk volume of coarse aggregate. This was aggregate size. Unit bulk volume in meter cube per meter cube, and it says for 15 mm 0.58 meter cube per meter cube for 15 mm. For 20 mm 0.62 meter cube per meter cube. For 25 meter cube 0.67 per meter cube, and for 40 it is 0.72 per meter cube. Bulk volume of coarse aggregate 0.58, 0.62, 0.67, 0.72. Air content for 15 mm 7%, for 20 mm 6%, for 25 mm 5%, for 40 mm 4.5%. With air entering agent, otherwise with air entering water reducing agent. So we consider first with air entering agent, sand percentage is S over A. S over A, that is sand percentage 47%. Sand over aggregate, S over A. Sand over aggregate and sand over coarse aggregate, that is 47%. Sand should be 47% of aggregate. In 20 it should be 44%. In 25 it should be 42. In 40 it should be 39. That is 47%. Water content is 180 kilogram in 15, and in 20 it is 175. In 25 it is 170. In 40 it is 165. Of course, when the reducing agent is also taken in that case with air entering water reducing agent, sand percent, that is the is in place of 47 is 48, 45 is 44, 44 is 45, and 42 is 43, and 30. So is not much increase, 1% increase. And water reducing agent is added, and water content are reduced by 10. You can say everywhere. 180 goes down to 170, 175 goes down to 165, 170 goes down to 160, and 165 goes down to 155. And because water reducing agent is added, these values are average determined with reference to standard mix proportions adopted by ready mix concrete industrial associations in Japan For concrete made by using sand of an ordinary particle size distribution and crushed stone. Appropriate amounts of correction for sand percentage and water content due to variations in quality of materials used or concrete. Category is given, then correction of S over A is given in percentages, correction of W is given. This correction, that is approximate amounts of correction for sand percentage and water content. For every 0.1 in fineness modulus of sand greater than reference value, increased or decreased by 0.5%, no correction. That is for every 0.1 in fineness modulus. For every 1 centimeter in slump, so fineness modulus of 0.1, and for every 1 centimeter in slump greater than reference value, no correction, increase, that is water, or decrease by 1.2%. For every 1% in air content higher or lower than reference value, decrease or increase by 0.5 to 1, and decrease or increase by 3%, that is correction of W. For every 0.05 in water cement ratio higher than lower than reference value, increase or decrease by 1 S over A 1%, no correction. For every 1% in sand aggregate higher lower than reference value, no correction percentages, increase decrease by 1.5 kilogram. When river gravel is used, decrease by 3 to 5 is correction percentage S over A, and decrease by 9 to 15 kilogram. If unit bulk volume of coarse aggregate is used, bulk volume of coarse aggregate is decreased or increased by 1% for every 0.1 in fineness modulus of sand greater or smaller than reference value. This is the important table for guidance purpose, and it's for mixed design, and these 3 points which are given regarding category, correction of S over A percentage, correction of W. It's very important one. Unit quantities of admixtures. Unit quantities of admixtures. We can say effect of admixtures varies depending on not only on characteristics of each admixture but also nature of cement and aggregate, type of other admixtures used, concrete mix proportions, construction conditions, environmental conditions, etc. Quantities of admixture to be used, therefore, required to be determined according to these conditions by testing respective performance under realistic service conditions or consulting literature or experience. Combined use of 2 or more types of admixtures may have unexpected adverse effects on properties of fresh concrete and performance of hardened concrete. When using a new combination of admixtures, therefore, a thorough study should be conducted in advance. Effect of admixtures varies depending on characteristics of each admixture, but also nature of cement and aggregate, type of other admixtures used, concrete mix proportions, construction conditions, environmental conditions. Quantities of admixtures to be used, therefore, required to be determined according to these conditions by testing performance under realistic service conditions, consulting literature or experience. Combined use of 2 or more types of admixtures may have unexpected adverse effects on properties of fresh concrete and performance of hardened concrete. and using a new combination of admixtures. Therefore, it's very important one, trial mixing, and it requires something. We have to be serious about trial mixing. Before that, I'll check something. I'll check it. So we can say here now trial mixing. Trial mixing. Trial mixing. Concrete mix proportions shall be determined through trial mixing so that concrete that meets mix requirements can be obtained. It's important, of course, trial mixing. I again remind you about my email, suraj_engineer@yahoo.co.uk, and I remind about quality. Quality, that is very important point. Cannot do without that. Real quality and real coordination, and also coordination, that is here important one, and of course you can say, just to again, concrete mix proportions determined through trial mixing so that concrete meets requirements, mix requirements. Trial mixing of concrete should be conducted in form of laboratory testing. Trial mixing may be omitted if it can be. Trial mixing may be omitted if it can be ascertained from performance data that planned mix proportion meets mix requirements. Trial mixing shall be conducted in order to ascertain that mix proportion determined at mix design stage meets mix requirements. Trial mix to be conducted in order to ascertain that mix proportion determined at mix design stage meets requirements. Concrete performance changes influence of various factors. Fresh concrete is subject to considerable change depending on time after completion of mixing, its ambient temperature, on-site transportation methods, When designing concrete mixes, it's important to set quality goals at each stage, that is production stage and unloading stage, so that concrete workability required at placement stage can be attained. This section requires, therefore, concrete mix proportions be determined through trial mixing prior to placement of concrete, so that concrete that meets performance requirements can be obtained. Trial mixing shall be conducted on an as needed basis under direction of Chief Concrete Engineer or Concrete Engineer certified by Japan Concrete Institute or an equally qualified engineer, which says that concrete mix proportions be determined through trial mixing prior to placement of concrete, so that concrete meets performance requirements can be obtained. Trial mixing shall be conducted on an as needed basis under direction of a chief concrete engineer or concrete engineer certified by Japan Society. Now, in order to determine concrete proportions through trial mixing, it's necessary to measure materials of proven quality accurately and mix them thoroughly. That's why laboratory testing is required, standard method. If, however, conditions under which concrete is produced in laboratory test environment differs from conditions under which concrete is to be produced for construction, or if changes in concrete quality over time are to be evaluated, trial mixing of concrete should be conducted by using real mixers. Trial mixing method. Trial mixing method. Trial mixing is conducted in form of laboratory testing. Trial mixing is conducted in form of laboratory testing, so that concrete that meets mix requirements can be obtained. When trial mixing is conducted in laboratory test, workability upon completion of mixing is evaluated, taking into account difference in slump from results of tests conducted by use of real equipment, concrete temperature at time of construction, mixing performance, transportation time. Trial mixing of concrete should be conducted at 20 plus minus 2 degrees Celsius as standard. If trial mixing cannot be carried out under such test conditions, mix proportions shall be determined after making corrections for temperature difference. In a mix test using a test mixer, appropriate test items shall be selected So we can say trial mixing of concrete should be conducted at 20 plus minus 2 degrees Celsius as a standard. If trial mixing cannot be carried out under such test conditions, mix proportions shall be determined after making corrections for temperature differences. In a mixed test using a test mixer, appropriate test items shall be selected so as to evaluate workability of concrete. Now, what is commentary about this? You have to give some comments as well, it's all that. Mixed design stage. When it is mixed design stage, target slump at undergoing locations and target slump upon completion of mixing shall be determined. At mixed design stage, target slump at unloading location and target slump upon completion of mixing shall be determined on basis of minimum slump for placement. Taking into consideration account transportation time, waiting time at construction site, and decrease in slump due to on-site transportation. In trial mixing, conducted in form of laboratory testing, therefore it's necessary to make repeated corrections for mixed proportions to achieve target slump at unloading location or target slump upon completion of mixing. Until required minimum slump for placement can be obtained. In trial mixing conducted in form of laboratory testing, therefore it's necessary to make repeated corrections for mixed proportions to achieve target slump at unloading location or target slump upon completion of mixing until required minimum slump for placement can be attained. Taking into account decreases in slump not only immediately after completion of mixing but also after passage of time concerning mixed proportion corrections. If large amount of decrease in slump is assumed at mixed design stage, time dependent changes in slump during time from completion of mixing to placement of concrete should be estimated. If trial mixing has indicated possibility of large amount of decrease in slump over time, it's important to select mixed proportions with an excellent slump retaining property and take necessary means such as using appropriate chemical admixtures so that minimum slump for placement can be attained. In general, amount of decrease in slump of a concrete mix interruptedly agitated in a mixture tends to be smaller than that of small batch. If a large amount of decrease in slump is assumed, the mixed design state, time-dependent change in slump during time from completion of mixing in place of concrete should be estimated. If trial mix has indicated a possibility of large amount of decrease in slump over time, it is important to select mixed proportions with excellent slump retaining property and take necessary measures such as using appropriate chemical admixtures so that minimum slump for placement can be attained. In general, amount of decrease in slump of concrete may uninterruptedly agitated in a mixture tends to be smaller than that of small batch concrete kept in static state in laboratory. As a rule, it may be assumed that slump retention time in a mixture test is about 30 minutes, longer than that in laboratory test. Mixing performance values widely depends on mixer type. Mixing performance varies widely depending on mixer type, so that quality of freshly mixed concrete and subsequent changes in quality are greatly affected. Mixer used in laboratory testing therefore should be of same type as mixed used for construction. So that mixing performance varies widely depending on mixer type, so that quality of freshly mixed concrete and subsequent changes in quality are greatly affected. Mixers used in laboratory testing therefore should be of same type as mixer used for construction. Trial mixing in laboratory test should be conducted at constant temperature. Trial mixing in laboratory test should be conducted at constant temperature conditions if time of, that is 20 plus minus 2 degrees Celsius, if time of year when trial mixing is conducted differs from time of year when construction is carried out, and a considerable difference in placing temperature is expected. Mixed proportions need be determined taking into account that temperature difference. Trial mixing in laboratory tests should be conducted at constant temperature conditions 20 plus minus 2 degrees Celsius, where time of year when trial mixing is conducted differs from time of year when construction is carried out, and a considerable difference in placing temperature is expected. Mixed proportions need be determined taking into account that temperature difference. It's also good practice to conduct trial mixing by using mixers and correct mixed proportions derived through laboratory testing. Concrete shall be provided with workability suitable for construction tasks such as hauling, placing, compacting, and finishing according to construction requirements, structural requirements, and environmental conditions. In concrete mix tests, it is important to check whether mix proportions is specified at max. Concrete shall be provided workability suitable for construction tasks such as hauling, placing, compacting, and finishing according to construction requirements, structural requirements, and environmental conditions. In concrete mix tests, it is important to check whether mix proportions specified at mix design stage have targeted performance with respect to filling ability, pumpability, setting properties, and strength development characteristics. Here is representation of mixed proportions. We'll go into this, and this is just a general rule. Mixed proportions should be presented in shown table, representation of mixed proportions. And there are various columns in that: maximum size of coarse aggregate mm, slump centimeter, air content percentages, water cement ratio percentages, sand percentage in relation to aggregate, that is sand aggregate, percentage water, cement, that's contents kilogram, of course, water in kilogram, cement in kilogram, mineral admixture in kilogram, fine aggregate in kilogram, and coarse aggregate, that is G, and that is mm, and of course chemical admixtures. And note 1 says standard methods to indicate target slump at unloading action, unloading location. This is standard methods to indicate target slump at unloading location if necessary. Minimum slump for placement and target slump upon completion of mixing are also indicated. If a mineral admixture with pozzolana, reactivity or latent hydraulic properties is used, water cement ratio becomes water binder ratio. Powder content should be then it becomes, if a mineral mixture with pozzolana reactivity of latent hydraulic properties is used, water cement ratio becomes water binder ratio, and powder content should be indicated as combined content of cement and mineral mixtures, as in evaporate cement. Powder content should be indicated as combined content of cement and mineral admixtures as an appropriate indicator of segregation resistance. If two or more types of mineral admixtures are used, mixed proportions for different types are indicated separately on an as needed basis. Chemical admixture content is indicated in milliliter per meter cube or gram per meter cube, and quantity of undiluted and undisclosed liquid be indicated. We can say as general rule. Now, as a general rule, mixed proportions should be indicated by mass and content of each ingredients used in each cubic meter of mixed concrete must be indicated in form of mix. So we'll see it's a general rule, and before going over there, we have to see that this says, as a general, mixed proportion should be indicated by mass and content of each ingredient used in each cubic meter of mixed concrete must be indicated in form of mixed table. You see, mixed table should also show information such as type of structure, specified strength, required strength, type of cement, fineness modulus of fine aggregate, type of coarse aggregate, solid content of coarse aggregate, transportation time and time of year of construction. Recommended standard practice is to indicate target slump at unloading location in mix tables, and if necessary determine slump at each stage of construction from immediately after completion of mixing to placement of concrete. It's also good practice to indicate combined content of powdery materials. Such cement and mineral admixtures to show whether segregation resistance appropriate for slump level is being maintained. Concrete production. We have covered some good part today. I think some quality mix part of concrete. It's very significant from every viewpoint. You cannot do without that. You have to consider that importantly at every location. It's very important one to consider that. It should be in every respect. We have to understand what we're talking while talking. It's really important to understand that one, and we have to be careful about this. Concrete production. Concrete with required quality shall be produced. Of course, it must be, and we cannot say no. There is no way out. There is no way out about that. It has to be like that. We cannot say no to this. It has to be accordingly. Concrete with required quality shall be produced. Equipment used for storage, batching and mixing of materials shall be one that has been verified to have required performance. Methods of storing, batching and mixing materials by using equipment with requirement performance shall be determined prior to production of concrete. Specialists with sufficient knowledge and experience shall be assigned to production of concrete to control quality of concrete materials, production equipment in concrete. So let us be generally very simple. That required quality shall be produced, that is concrete requirement. Concrete with required quality shall be produced, no other way. And whatever equipment is used for storage, for batching, for mixing of materials should be one that has been verified to have required performance And whatever method of storing, batching and mixing conc materials by using equipment with requirement performance shall be determined prior to production of concrete. Specialists with sufficient knowledge and experience shall be assigned to production of concrete to control quality of concrete materials, production equipment and concrete in order to produce concrete with concrete with required quality. It is important to use equipment with required performance, use appropriate production methods and have specialists capable of ensuring stable quality of concrete, perform quality control. Use of equipment with required performance is most fundamental and important for production of concrete. Even if concrete materials meet quality requirements specified, inadequate production equipment increases possibility of fluctuations or degradation of quality of stored material. Fluctuations in mixed proportions due to batching errors and fluctuations of properties of mixed concrete, thereby making it difficult to obtain concrete with required quality stability. Even when storage, batching and mass mixing equipment meet performance required, it's difficult to obtain concrete with required quality if concrete is produced without ascertaining in advance that storing, batching and mixing methods are appropriate, as in case where inadequate equipment is used. Performance requirements are we'll go to this is on page 140, and I think we will go for the next pages next time. Production plant we'll discuss, and we will discuss about measuring equipment, and we have to discuss about mixers, we have to discuss about capacity of batch, measurement of material, and whatever errors could be there, we will discuss. It's of course an interesting one if you are serious, otherwise no meaning at all. If you're not serious, we have to be very, very comfortable with this. Now we have gone through today with many points here. We have gone through good temperament of reading, of referring and talking of quality and coordination, and of course it's very important for everyone, but everyone is not capable of all this. Now we're talking of concrete quality, which can't be avoided. Quality is quality, it's money, it's time, it's risk, everything, and we can't do without that. There's no way out. We can't say yes or we can't say no, we have to do it. There is no other way. If you think there's another way, then we think we live in a wrong world. We live in a wrong world. Quality cannot be disregarded, and of course quality related issue, and that is coordination, at no cost can be disregarded, because it is coordination that will help us at every point. You have to know what's happening inside. So we have to take this point into consideration that quality is very important, and our quality is not only important, it's a must. You can't do without that. And you may say that real quality and real coordination, everybody has to do it practically. We cannot avoid this, and we have to change our culture. I have to think ourselves, man. No, there's no question of any supervision or surveillance. It's the job of engineer and engineers, employees or engineers workers. And one all should take care of them. It includes every facility, which is in limits of your studies. There's a question here. We have to see every stop. Everyone stop sleeping. Everyone has to stop sleeping from this viewpoint. It's a very, very important one. And if you cannot do that, if we cannot do that, we don't do our job. We are not honest to ourselves. We are not sincere in that case to ourselves, our conscience, our minds. Because mind never asks you to do wrongs. You say, we'll see when I go there. Wait for that. Go there now. That's point for having a serious about, it's a very important point. You can't do without that. Quality has to be maintained by engineers cannot. Engineers can handle it. There's no way out. There's no way out. We have to. There's no concession on that. If you see concession, you're in wrong path. You're in wrong world. We have to see. We have to establish both permanently, and we have to do it. Reliable quality engineering, and reliable coordination engineering we must deserve. Cannot say no. Fix your quality in Bharat, India, come what may. We have to see this very seriously, this issue, and and say it's not just for me, for you, it's for everybody. You have to think of that and do it. You have to do it. There exists no other way. We have to do it means we have to do it, and I understand that engineering community will realize this fact. They will be serious about this fact, and not only otherwise. They will be serious about this fact every time. And they should do it rather than ignoring it. Ignoring would not help. Doing is required, and therefore we can say we have to be serious about this issue. I would say, what else? Quality has been alive to see something else also. I don't know. Chassis, coalition in concrete, and this isn't a certificate, and this is about concrete melamine. We discussed that melamine after last time. Open access production, and this is see this also. Of course, this is sometimes I could not show you all this. It's better. See, my podium. I actually tried to discuss with you all this. I could not do that, and it is I should discuss because you should know what's my best basis as to how you can benefit of that. think it is gone. Something happened, something. It should work. It's not working. I don't know. We overload on files. Actually, I tried to define something for purpose of those who as far as my own brief. It's very small, very brief in this. I just thought I have multifaceted personality in project organization, management, engineering designs and construction, contracting, site and office engineering, with full adaptability and required acumen, professionally dedicated, experience having worked under stress and resilience to achieve target objectives, reliable knowledge and dissemination to public and professionals, social media forms like Facebook, Safi, LinkedIn, various sections are available. Many companies we worked, as you can see, I worked many companies, and that is here. You may say that was for pad engineering. For pad engineering, I worked for many projects of QDVC, VC, QVC, PO Netco, typical for Ilmesnad, US Army Base, Karama, etc. And I also allow agency established in Saudi 500 beds North Jid Hospital project. And that also likewise. So many parts of this CV available, and we'll take time to discuss them together sometimes. Meanwhile, just closing this, because this reference I'm showing to you. Otherwise, I'm closing this also now, and we'll see what else to do. I'm closing this scenario today. Now it's almost. I'll take your leave now. Thanks a lot indeed.